Welcome to this explainer. Let's jump right into a genuinely mesmerizing, visually striking hypothesis about the origin of life. When we normally think about how life began, our minds go straight to sterile laboratories, bubbling test tubes, or maybe a dramatic lightning strike over a pool of primordial soup. But today, we're starting somewhere completely different. We're going to look at a simple, everyday winter snowfall.
This whole concept actually kicks off with a super relatable moment. Picture this. The author, Sergey Mametyev, is just sitting in his warm car at a service center during a heavy winter snowstorm. Time is dragging on, the music's playing, and it's a bitter -10 degrees Celsius outside. But inside, toasty warm. He's watching the windshield, the wipers clear the glass, but within seconds, the streaks form again. And he gets completely captivated by how these tiny pieces of ice slide down the water rivulets on that hot windshield. They don't just melt instantly. Instead, they slide down, continuously meeting new falling flakes without completely melting all at once.
And here's where that everyday observation turns into a profound realization. He noticed that the extreme temperature difference between the freezing air outside and the hot glass inside created surface tension. This surface tension actually allowed the meltwater to envelop the small remaining ice crystals. So they could run down the glass together, meeting discretely, melting, and combining their tiny payloads. Basically, that windshield was acting as a continuous, naturally running conveyor belt.
Section 4. The Great Mystery. From Snow to Prebiotic Chemistry.
So why does a mundane observation at a car mechanic build into something so profound? Well, it attacks one of science's biggest open questions. We already know the basic building blocks of life, right? We understand the chemistry of simple organic molecules. But the exact mechanism that bridged that massive gap from simple, lifeless molecules to complex, self-replicating living systems, that's always been a mystery. How exactly did all that chemistry get so perfectly organized?
To solve this, we kind of have to rethink how nature operates. It's highly unlikely that nature relied on just a single, miraculous, lucky accident. A one-off lightning strike hitting a puddle might create a few amino acids, sure, but it doesn't build a complex system. What nature really needed was an enduring, relentless mechanism. It needed a way to create, mix, concentrate, and test an absolutely enormous number of chemical combinations over millions of years. It needed a continuous testing ground.
Which brings us to this absolutely crucial concept, a discrete chemical conveyor. In the context of our winter scene, think of every single snowflake as a tiny, isolated capsule, a carrier of matter. As it falls to the atmosphere, it picks up dust, salts, minerals, maybe simple organic molecules. It brings those exact ingredients down to the surface, melts, and uniquely mixes its payload with others. And it does this in a perfectly repeatable process.
Section 8. The Early Earth Factory. Translating the windshield.
Okay, let's take that windshield analogy and drop it right into the brutal primordial environment of early Earth. Our young planet wasn't just some calm, warm pond. It was a place of dramatic, violent extremes. Picture a landscape where brutal cold, falling ice, and meltwater are constantly colliding with the intense heat from hot rocks and cooling lava. That hot, cooling lava of a primordial volcano behaves functionally just like the hot glass of the car windshield. It creates endless, continuous phase transitions between solid ice, liquid water, and vapor.
In these extreme dynamic conditions, you suddenly have all the right ingredients. As ice slams into hot volcanic rocks, water forms thin films, droplets, and running rivulets. And crucially, surface tension holds these tiny microenvironments together. It keeps the chemical ingredients concentrated instead of just diluting them away in some massive ocean. You've got underlying minerals in the rock acting as chemical catalysts speeding things up, while meteorites, harsh UV light, and radiation are constantly bombarding the surface, fueling these reactions with brand new substances and energy.
Section 11. The Prebiotic Snow Engine.
Here's the core engine, the real beauty of the snow hypothesis. It all boils down to this endlessly discrete, relentlessly repeatable four-step process. First, the snowflake forms, acting as your unique carrier of matter. Second, it hits a warm surface and starts melting. That's your phase transition. Third, its unique contents enter a thin film of water, which allows for mixing and chemical concentration. And fourth, it's transported via surface rivulets to collide with the next melting snowflake, kicking off a brand new, totally unique chemical reaction. Over and over and over again.
Section 13. The Math of Creation. Scaling the Microreactor.
To truly wrap our heads around the power of this hypothesis, we need to scale up. Way up. From a single microscopic droplet to the massive scope of planetary time. Let's just pause and absorb this number. 10 to the 22nd power. Experts estimate that about 10 to the 22nd snowflakes form and fall on Earth every single year. That is a staggering, almost unimaginable number of microscopic, individual chemical delivery vehicles arriving continuously.
Now, take that annual number and run the clock. If this continuous natural conveyor belt operated for, say, at least 1 billion years during Earth's early history, the total number of these microscopic mixing events could reach a mind-bending 10 to the 31st power. That is an incomprehensible number of discrete chemical experiments being run by nature. It's quite literally the ultimate trial and error machine.
And honestly, we don't even have to stop at Earth. Zoom out further. When we account for other planets, exoplanets, and massive water-ice cycles happening throughout the entire cosmos, the sheer volume of these chemical attempts grows so incredibly massive that the mathematical probability of life arising naturally basically approaches 1. Given enough unique snowflakes and enough billions of years, the right complex molecular structures are practically bound to form.
Section 17. Synthesizing the snow hypothesis.
So let's bring all of this together. Now, it's super important to note, we are not saying life arose only from snow. That would be a huge oversimplification. Rather, this global water-ice cycle was a massively powerful mechanism, a primary engine of prebiotic chemistry that concentrated, mixed, and selected molecular structures on the long path toward life. Summarizing the author's work at snowislife.com, here are the big takeaways. The snowflake acts as the capsule. The act of melting initiates the microreactor. Water films provide the perfect mixing medium. Hot surfaces and minerals offer the vital energy and catalysis. And finally, billions of years of repetition serve as a massive, unparalleled evolutionary search engine, hunting for the exact chemical combinations of life.
So the next time you're sitting in a car or looking out a warm window during a winter snowfall, look closely at those melting flakes sliding down the glass. Watch them meet, mix, and move on. And ask yourself, if this incredible, relentless natural conveyor belt helped build the very machinery of life right here on early Earth, where else in the vast universe is this exact same conveyor running right now? Thank you for joining me for this explainer. Keep wondering and keep looking closely at the world around you.